Hello, Big Reds. This is Mr. Fisher again. This is part 2 of your exam review video right here. So we'll start with a new sheet of paper, and we're going to talk about these angle measures, assuming that these are parallel lines. This is a transversal that cuts through the parallel lines. Now the numbers will probably not be numbered the same on the exam, so don't memorize the numbers, memorize the positions. That's what you need to know. So we'll start with angles 4 and 8. What are angles 4 and 8 called? Well, if you look at this, angles 4 and 8, if we block out the middle, let's see if I can do a better job here. Blocking out the middle here. If we look at just the outside, 4 and 8, those are on the outside and they're in alternate spots, so those are called alternate exterior angles. Okay? Alternate exterior angles. Then, if we look on the inside, and if we're talking about the inside, I'm going to block off these parts right here. Inside, angles 6 and angle 2 are alternate interior angles. Okay? Because they're in alternate spots, they're both inside of the parallel lines. Angles 6 and angle 7 are consecutive interior angles. Okay? Consecutive interior, meaning they're on the same side of that transversal. Notice, they're both interior. So that means they're both on the inside of the parallel lines. Next, if I have something like angles 5 and 7, those are both in the same position. You see this is on the top left of this group of angles. This is on the top left. So those are going to be corresponding angles. You need to remember those types of angles. I know it's been a while since we've done it, but you got to know those angles. Now, let's say if angle 4 is 70 degrees, what would angle 5 be? Well, since they're a linear pair, they add up to 180. I could take 180 minus 70, give me 110 degrees. So angle 5 is going to be 110 degrees. Okay. All right. Next, another sheet. Flip it over. Here we go. We'll talk about this one first. Okay, we want to describe this transformation. You can see we have an object, a polygon, moving from here to here. You can see it's starting here with the image, going to the pre-image here. This is the pre-image. This is the image. You can see A goes to A prime, B to B prime, C to C prime, and D to D prime. How would we categorize this transformation? Well, it is a translation. And let's see, a rule for that would be, you could see the y is not changing, it's not moving up or down, so the y stays the same. The x is going to left, so the x is being subtracted. We're just going to make up some number. We're going to say 8. So it's going to be x minus 8 y, because you could see x value is getting less, the y value is staying the same. So this would be an example of a translation rule for this example. Remember, you're starting here, starting with the ones that are not prime, going to ones that are prime, pre-image to image. Right down here, you can see we're starting with A, B, and C. We're going to A prime, B prime, and C prime. And this is a reflection over, let's see, it's a reflection over this axis, which is the y-axis. All right. Reflection over the y-axis could also be categorized as x equals 0. So either one of these would work. Reflection over y-axis or x equals 0. This is the same thing. Okay, next. Going to this one. You see D is going to D prime, F to F prime, E to E prime. You can see it's being rotated, so it's a rotation. And with this rotation, how many degrees are we going? Well, it looks like we're going from here to here, so that would be 90 degrees clockwise, or we're going this direction, we're going 270 degrees counterclockwise. So remember, look at, this is the pre-image, this is the image. Make sure you're starting from this one, going to this one. That's very, very, very important. Okay, all right, next. Let's say we have some points. I'm going to make them up. I'm going to call them A, B, and C. We'll say this is 3, 3. This one is 2, 10. And this one is 8, 5. And what we want to do is we want to do a composition of transformations. So first of all, we want to translation. That goes xy goes to x plus 3, y plus 2. And then we're going to dilation by a scale factor with the origin as the center with a scale factor of 1/2. Okay? So first thing I have to do is I take these points, I do this one first. So I'm going to go from A to A prime, B to B prime, and C to C prime. A to A prime, I'm adding, you can see for each of these I'm adding 3 to all the x's. So I take 3 plus 3, which is 6, 2 plus 3, which is 5, 8 plus 3, which is 11. Then I do add 2 to the y's, so 3 plus 2, which is 5, 10 plus 2, which is 12, 5 plus 2, which is 7. After I do this, then I take these new image points and I want to change them to make brand new image points, okay, that are A double prime, B double prime, and C double prime. So I multiply them. When I'm doing dilation, I multiply by that 1/2. So I take 6 times 1/2, which is 3, 5 times 1/2, which is 2.5, 5 times 1/2, which is 2.5, 12 times 1/2, which is 6, 11 times 1/2, which is 5.5, and 7 times 1/2, which is 3.5. Okay? And these would be your answers right here. This is just the in-between step. This is your final answer for this problem. Okay? Okay, next. If I have a situation like this, where I have a dilation going out from the center, I have A and B. Let's say this is A prime and B prime. And I'm going to have some points here. Let's say I have 3, 6, and I have, let's see, this will be 9, 18. And the points here will be, let's see, 2, 5. And here this will be 6, 15. Or, I'm sorry, let's say we don't know what those are. How do you figure it out? First of all, you have to look at scale factors. Scale factors, how much is it changing? Going from A to A prime. You can see going from 3 to 3 times 3 is 9. 6 times 3 is 18. So the scale factor is 3 because we're multiplying by 3. Now if we look here, if we want to get what B prime is, we multiply these by 3 as well. So I take 2 times 3, which is 6, 5 times 3, which is 15. So you should be able to do these type of problems as well. All right. See you in a little bit. End of part 2.